So this is the second part of 2.1. We just talked about triangles, the distance formula, slope, midpoint, and now we're moving on to circles. So this is the equation for a circle right here. X minus h squared plus y minus k squared equals r squared. The center of the circle is hk, and then the radius of the circle is represented by r. So in the equation, the radius is squared, but the radius is just r by itself. So you might be given the equation of a circle and asked to graph it. So you will need to know those key pieces. You'll need to know the center and you'll need to know the radius. So noticing the equation, it's minus h, but the center is just h. So here where we have a minus 2, the center is going to be 2, that's your h value. And then y minus 3, that's your k value, so 2, 3. And then remember, this is r squared, so we have to take the square root of that value right there, the square root of 4, to find out what r is. We know that r is 2, because 2 is the square root of 4. So then when you go to graph it, you go to the center first, so 2, 3, and then go out, since our radius is 2 points in every direction. And then do your best to draw a non-egg looking circle. It's kind of hard. Hopefully you have some graph paper to draw it on. If not, you might really look strange on your lined paper. Okay, and that's all there is. So let's take a look at another circle. Again, at any time, if you need to pause to be able to get everything written down, just hit pause, write it down, and then come back. All right, so here we want to graph the equation of the circle x squared plus parentheses y plus 5 squared equals 24. Looks a little different from our last one because there's nothing being subtracted from the x. So that just tells us that the x coordinate of our center is 0. Also remember that the equation of a circle has a subtraction sign. So the fact that there's a plus, an addition sign right here, tells us that this 5 is going to be a negative 5, because the negative 5 turned the subtraction sign into a positive. All right, and then we have to take the square root of 24 to find out our radius. And most of the time when we do square roots, we find a perfect square and break it down. But for graphing, we need to know exactly what that value is. So since it's not a perfect square, we can use our calculator, take the square root of 24, and find out that it is approximately 4.9. So then we will go to the graph. Graph 0, 1, 2, 3, 4, negative 5. And then 1, 2, 3, 4, not quite to 5 here. 1, 2, 3, 4, not quite to 5 there. So we're putting a dot a little bit shy of a radius of 5. And then again, we have to try to be careful to draw what would look hopefully like a circle. Sometimes they look better than others. All right, so now instead of giving you the equation of a circle, number 6 gives us some information and we have to write the equation. So find the equation of a circle with center 4, 3 and radius square root of 5, and then sketch the graph. All right, so we're gonna put those into our equation. So we have x minus our h value, so x minus 4 squared plus y minus 3 squared equals, remember that when you put the radius in, it's squared. So square root of 5, we have to square it. Now, in the actual equation of the circle, you don't want to leave that unsimplified. So for our final answer, x minus 4 squared plus y minus 3 squared is all okay, but you actually have to square the square root of 5. Square root of 5 squared, a square root and a square cancel each other out. So we get equals 5. So this is our equation, and then we can graph it. So we start by graphing the center, 4, 3, but then in order to use our radius, we need to know approximately how much is the square root of 5. So in your calculator, you can find that it's approximately 2.2. You only need to go to the tenths because you can't graph to the hundredths. So 2.2 is good. So we'll go a little past 2 in each direction. And then do our best to draw a circle. All right. Hopefully you're starting to get familiar with the circle, because now we're going to start incorporating some of the information that we talked about in the first part of 2.1. We want to find the equation of a circle that has center 7, 1, so we know what the center is. It says, but it also contains the point 1, negative 7, and then sketch the graph. So you might notice that we're missing the radius. So we know that the center is 7, 1. 1, 2, 3, 4, 5, 6, 7, 1. And we know that the point 1, negative 7, 1, 2, 3, 4, 5, 6, 7, is on the graph. But we don't know that length. So the length from the center to the point is called the radius. So the center to any point on the circle. But we don't know what it is. So how do we find that length? Well, the distance formula. So in order to find the radius, we need to use the distance formula for those 2 points. So we're going to do 7 minus 1 squared plus 1 plus 7 squared equals square root of 100, which is 10. So our radius is 10. So we can write our equation now. We can say x minus 7 squared plus y minus 1 squared equals, remember we'd say 10 squared because our radius squared, but then that wouldn't be simplified. So 10 squared is 100 for our simplified answer. Now, I can tell I had some poor planning here because when I try to count by 10 in each direction, it's not going to work. So if I was using pencil, I would need to erase what I had already done and find a new scale to use. So I'm telling you, don't do as I do here. Looks like I'm only going to be able to get about half, maybe a little bit over half of the circle represented. Part of it's going to go off the page and off the graph. We don't want that typically. So most of the time we want to make sure that we change our scale so that we can get everything on the page. All right, last one. We're going to find an equation of the circle. It's giving us the diameter, endpoints of the diameter, but it didn't give us a center and it didn't give us a radius. All right, so here I can already tell at the beginning, if we have to use 11, I'm going to have to count by 2's to get there. So I'm going to put the point 5, 1, so 2, 4, 5. I'm going to put my scale as 2 here so that we know. 5, 1, and then 6, 8, 10, 11, 7, so 2, 4, 6, 7. So that's the diameter of the circle. So that goes from one side of the circle to the other side of the circle. So how are we going to find the center? Well, the center is in the middle of those 2 points, so we can use midpoint. We haven't used that back in any of these yet, except for that first example we did, but midpoint's taking an average. So we're going to average 5 plus 11 divided by 2 and 1 plus 7 divided by 2. That gives us the midpoint of 8, 4, which if we look at it, 2, 4, 6, 8, 2, 4, it's right there. So that confirms what we do on a graph. You always want to confirm with algebra what you see on a graph because graphs are not very precise. All right, so now we know that the center is 8, 4, but we still don't know the radius. Okay, so two different ways we could go about finding the radius. You could find the length of the diameter and then cut it in half. Or you could use your center and find the distance from the center to one of the sides, which we did on the last one. So maybe we'll try finding the length of the whole diameter. And then we'll cut it in half. All right, so we're gonna do 5 minus 11 squared plus 1 minus 7 squared, which equals the square root of 72. Okay, if we simplify that, that is 36 goes in there, so 6 radical 2. That's the diameter. Cut it in half to find the radius would be 3 radical 2. So our radius is approximately 4.2. So we can go 4 and a little more. 4. Remember that we're counting by 2's here, so you don't count by 1's when you put your radius on there. All right, and then we need to actually write the equation of the circle as well. So we take our center 8, 4, and we're going to say x minus 8 squared plus y minus 4 squared equals our radius squared. And notice that when I put the radius in, I put it in parentheses. You have to do that in order to get the right value. If you just write 3 radical 2 squared, it will only square the radical. It won't square the 3, but both of them have to be squared. And then we need to simplify that radius. So our left side stays the same, but if you square a 3, that's 9. Square radical 2, that's 2. 9 times 2 is 18. And there you go. So that is the second half of 2.1, all about circles. Get to use circle equation, distance formula, midpoint, all sorts of good stuff there.